This is a collection of the large introns where the lines have been broadened and the colors changed. This is the image rotating around, and you see this is not particularly a large intron, but there are two dicer stems in this intron that effectively cut the structure into two parts. This is the prune of that's a full structure, and again here are the two dicer elements. This is somewhat larger structure that has just one dicer stem in it, and as always you can go up to the particular stem and zoom up and then put on the stem length signal, and you see that it's 25 bases long. This is the prune, so you see this prune has a pair of splits in it, these three element diversions. This is another structure. Again, the dicer elements seem to be in the middle of the structure. So you see the dicer elements here. There's just three of them, but the structure is quite separated by the dicer elements, and this is very clear in the prune structure, because once again the dicer elements are clear where they are. This is again a bigger structure, and the dicer elements are effectively separating the structure into two domains. This is its prune, and again the dicer stem can be located here. This is a more complex one, and you can see there's one dicer stem hiding in the middle of the structure. This is its prune. Its prune is a very simple thing, because there's so much arborescence in this structure. When you prune away all of the periphery, the leaves and then the branches and then the next set of leaves, you do this recursively, then the structure prunes down very strongly, and so there's very little left when you're finished pruning. Here's a dense structure. The dicer stem is there are one dicer stem, I guess, and this is its prune. Well, at that point, the dicer stem must have been on the periphery of that structure, because when the prune occurs, it's gone. So let's eliminate. So you can see that the one dicer stem there is out on the periphery of the structure. Yeah. And there's another larger structure. The dicer stems are here. There's quite a number of them. Look at that. And of course that should be seen quite clearly in the prune, because the dicer stems cut the fragments, cut the complete structure and the prune structure into many different domains. This is a larger structure yet, and again the dicer stems effectively cut the complete sequence into a bunch of domains, each of which would be freed by the dicer action. Again, look how complex this is. This pruning structure is quite beautiful. There, look at that. So you can see where all the dices are acting in the pruned image, and of course you can also see it in the full structure. Again, here's a structure that the graphic portrays as having very particular domains and dicer stems are here, and then this is its prune. And again, you can see exactly where the dicer stems are located. Once again, dicer is effectively cutting the structure, an intron, into several different domains. And here we can see, once again, where the dicer is acting. Another one. See, there are lots of dicer seconds stems in this structure, all over the place. And of course, that's very obvious in the prune structure here. So you see, the prune structures have quite a variety of different topologies. Again, here's a structure with a number of dicer segments, stems, and the prune structure has a different topology. Again, you can see where the dicers are located. And then, and here's the largest of the structures, and it has quite a number of dicer stems too. But I don't have a prune of that. So the purpose of this video is to show you how what the dicer elements do in the relatively larger intron structures. They have the effect of cutting the intron into a number of different domains, discrete RNA molecules. Some of them are small, and some of them are large. And the dicering has the effect of clipping up the intron into a collection of smaller segments. You'll want to look at the dicer cascade and more dicer cascade videos. They give you a better description of the process that dicer uses to decompose a given intron into a collection of fragments. Thank you.